Hey guys, this is a review for the calc test. I'll be posting how we're going to do the calc test. We're just still trying to figure out a way to have the calc test actually count for you guys. And so you're not like, it's not just a pass fail. But that's on us to figure out. So when I know, I'll tell you. But first, let's just look at this, x sine x dx. Now, I said use substitution. The problem is, for this one, you need to use integrate by parts. So we're going to use integrate by parts. So I'm going to call f of x. Now, remember, f of x wants to be the one that simplifies to something, like goes away, basically. So f of x, I'm going to make it x. Well, f prime of x, I'm going to make it 1. Because that disappears. Well, g prime of x, I'm going to say sine x. Now I need the antiderivative of sine x. The antiderivative of sine x, which is negative cosine x. Okay? So let's set it up. It's fx times dx. So fx is x times gx, I should say, is negative cosine x, minus the integral of f prime of x, which is 1, times the g of x, which is negative cosine x dx. All right, I moved the negative in front, so I got plus integral cosine x dx. Then we're going to do the integral on both sides, or the antiderivative. So antiderivative of cosine is a positive sign. So this is plus sine x. This is negative x cosine x. And there's a plus c over here. Okay, that's 1. All right, let's get to the next one. All right, we're on the next one. Square root of 7x plus 9. Now, since this is whole expression inside a square root, this makes it difficult to derive. So what we're going to use is u substitution. So I'm going to claim u is 7x plus 9. That makes it nice because then I can replace this whole 7x plus 9 with u. So, but I also need to replace dx. So I have to say du of dx equals, over here is going to be just 7. A little bit of algebra, du over 7 equals dx. So, since now I can replace both the dx and anything with the x, this becomes the integral of the square root of u and just du over 7. Now, du is a constant, so since du is a constant, it goes in front. So that is 1 over 7 integral, and I'm going to rewrite the square root of u as u to the half power du. Okay, so let's do the antiderivative of half a power. So we're going to add 1 to the integral, so 1 over 7. Add 1, so that's u to the 3 halves, and then divide it by the new one. So we're dividing it by the new one, so that's going to be the reciprocal, so 2 on top, 3 on bottom. All right, so let's simplify this. I actually know what u is. I'm going to resubstitute that. So I'm going to have 2. This is to the 3 half power, so I'll just write 7x plus 9 to the 3 halves power, all over 7 times 3, which is 21. Nothing more I can simplify, and don't forget your plus c. Okay, we're on the next one. Number 3, the integral of cosine 3x dx. So the cosine of 3x dx, it will become, well, I don't know what the cosine of 3x dx is, so I want to figure out what u is. So I'm going to call u 3x. I'm going to find du dx has to equal the integral of this, which is just 3. A little bit of algebra. Du divided by 3 equals dx. All right, and now I think I showed you the shortcut, or you know what it is when there's a constant, but let's just finish it off. So that's what we got. So now we have to redo. So we're going to rewrite this as the integral of cosine u, and then that's du over 3. Move the constant in front. So I got 1/3 cosine integral of cosine u du. The antiderivative of cosine u is sine u. Is, yep, positive sine u. So 1 over 3 sine u there's no du anymore because we integrated it already. So then we just have to plug in the constant. So it becomes sine 3x over x, or over 3, I apologize. So I just want you to show the simplistic version of this is that the fact of the matter is it's going to be sine kx over your k. Okay? And then it's whatever your antiderivative. So let's say you started with tan, it would be the antiderivative. I guess it wouldn't be. Let's say it was secant squared. Then the antiderivative would be tan kx over k. Okay? So that's the quick way, and this is the long way just to make sure if you want to make sure. All right. I will have to say for number 4, if you skipped ahead, number 4 is something that was called partial fraction decomposition. Now, that's not something I actively taught, and because I didn't actively taught it, I don't think it's proper for me to teach it to you or review it for it. So I'm going to remove something like that, so you could like erase number 4, cross out number 4. Sorry I didn't notice that earlier. All right, number 5. E sine x cosine x dx. Okay, so we notice we had an e sine x and a cosine x. We can't really use integration by part because we don't know what e sine x antiderivative is or the derivative of that is or something along those lines. So what we're going to do, I guess we could do chain rule, but since we could use chain rule, we're just going to use substitution. So I'm going to call u. We're going to make u sine x. And the reason I do that, because I know du over dx is going to become cosine x, which a little bit of algebra will make it dx equals du over cosine x. And what's convenient about that is I can replace the dx with that, and the cosines will cancel out. So rewrite this, e to the u power cosine x du all over cosine x. Hey, these are exactly the same top and bottom, so I could cross that out. So I have the integral of e u du. Now we're going to derive the du. Now e to the u simply is e to the u. So that's e to the u. And you know there's a plus c here somewhere. But e to the u. And then we're going to plug in u. So e sine x plus c. Oh, I'm sorry, I looked at the sheet. Some reason it said cosine x. No, it should just be cosine x. I don't know why he wrote that. I don't know why it came out like that. So I apologize for that. All right, next one. We have two things. We have a actual bounding, and we have something weird here like polynomials. Just a point. The reason I have to actually give you a bounding on this question is that there's a point here where the fraction doesn't exist, right? There's a point here where the fraction exists, where this becomes 0 in the denominator or -1. That's why I have to tell you from 0 to 1. All our integrals that are like, doesn't have signs or indefinite integrals have to be continuous throughout the whole section, like from infinity to -infinity. And this is not technically continuous. You have a removed discontinuity here. So I'm just pointing that out. But so we're still going to solve this problem. You don't need to know what I just said, but we're going to solve this problem. All right, so what's really confusing is that square root 1 plus 4 x to the 4th. So I'm going to rewrite that as u equals 1 plus x to the 4th. And then I'm going to make du dx equals, you take the 4 down, 4x to the 3rd. All right, a little bit of algebra, du over 4x to the 3rd equals dx. Okay, so let's do our substitutions. So from 1 to 0, x cubed over the square root of u times du over 4x to the 3rd. We have 2x to the 3rds here, so that cancels out. This 4 I can move to front. And then this u I'm going to rewrite. So we have a 1/4 in front. Sorry about that. 1/4 in front. The integral from 0 to 1. This u in the denominator, I'm going to rewrite as u to the negative 1/2 power du. All right, let's integrate that. 1/4. Now we're going to find the integral of that, which is, we're going to add 1, so that's to the 1/2 power, u, and then we're going to have to divide it by the new one. So divided by 1/2 is 2. Okay, but it was from 0 to 1, so we have to go from the range of 0 and 1. Okay, before I do that, I'll just substitute the u, so that'll be 2, and this is 1 plus x to the 4th half power. Or another way to write it, 2 the square root of 1 plus x to the 4th power from 1 to 0. Okay, so let's keep the 1/4 in front. 1/4. So we have 2 times, we're going to plug in 1 first, the square root of 1 plus 1, minus 2 times the square root of 1 plus 0. Okay, 2 times the square root of 2 here, minus 2 times the square root of 1 is just 2. All that times 1/4. I could take a 2 out, basically. So I end up, after doing all my work, the root 2 minus 1 all over 2. Because I could take out a factor out of 2 here and then just put it all over the same number. So my final answer is root 2 minus 1 over 2. Now notice there's no plus c, because remember, we had actual definite integrals. We don't need that plus constant. All right, let's do the next one. Funny enough, what you could do is just FOIL it out and then do each integral separately. Maybe I'll do that as a... Nah, I won't do that. Well, let's just follow the process of using u substitution. So u in this case is 9 plus x du. And remember, I put in 9 plus x because I want to get the fraction out. So the integral, that's 1 du dx. So that just means du equals dx. So from 3 to 1, this is just u squared du. And no issues there. So to integrate that, that is going to become u to the 3rd power, because I've raised it, over 3, because you divide the new power, from the range of 3 and 1. But before I do that, I have to plug it in. So that's 9 plus x to the 3rd power over 3 from 3 to 1. So 9x to the 3rd power over 3 to the range of 3 to 1. So 9 plus 3 over 3. I'm sorry. While this top part's to the 3rd power, minus 9 plus 1 to the 3rd power over 3. Okay? So the first one is 12 to the 3rd power, 12, 144. 12, 144, 1728. So that is going to be 1728 over 3 minus 10 to the 3rd power is 1,000 over 3. 1728 over 1,000 equals 728 over 3. If you want to simplify it, that would be, and that would reduce to 2, 402, and 2/3. Okay, either way is correct. You don't have to actually reduce it or anything, but these could be combined, so let's combine like terms like that. All right, so that's for that one. Number I think this is 7. Number 7. I also want to point out you could technically have polynomial out, so you have 81 plus x will be 18x plus x squared. And then from 3 to 1, and then add all those pieces. And you should get around the same answer, okay? Yeah, not around the same answer, you get the same answer. Just want to show there's a second way. And if you did do this way, I'll just show you, you have to separate, because they're pluses, you separate each one. 3, 1, 81 plus 3, 1, 18x plus 31x, all with the x's. Then you would do that. So that's 81 times 3 minus 1. And this will be, the integral of that would be divided by 2, 9x squared from 3 to 1. And then this one would be x to the third over 3, 3 to 1. So whatever way you find easier, you do that, okay? All right, the next one, number 8, is x cosine x dx. Integration by parts, similar to the sine one we did already. So let's just do it quickly. I'm sorry. F of x equals x. So f prime of x equals 1. G prime of x equals, we'll do cosine x, which means g of x equals the integral of cosine is just sine x. Okay, or the antiderivative of cosine sine x. All right, so let's do it. F of x times g of x minus the integral of f prime, which is 1, times the g of x, which is sine x, dx. Okay, so then we're left with sine x minus the integral of sine x. I'm sorry, x sine x minus the integral of sine x, dx. The antiderivative of sine x is negative cosine x, so that become a double positive, or double negative becomes positive. Cosine x, x sine x, plus c. So we can't forget the plus c guy. All right, the next one, the integral of x ln x dx. Okay, so for this one, if you remember, ln is, because it gets so complicated when we use the antiderivative of ln, we're going to make f of x ln x. Okay? So why that is good, because we could just derive it and it reduces down to 1 over x, which is a lot less worse than normal. So this becomes f prime of x equals 1 over x. Well, and then we have to do the same for g of x. So g prime of x equals x. So g of x, the antiderivative, is x squared over 2. Excuse me. Okay, so let's start working. F of x is ln x, so that's ln x times the g of x, which is x squared over 2, minus the integral. F prime of x is 1 over x times x squared over 2 dx, minus, now I can reduce this, so now I have just x over 2 dx. And then let's continue. 1/2 x dx. And then the other one, am I missing anything? No. And then we just use the antiderivative of x, so that again is 1/2. This becomes x squared over 2. And then x squared over 4 minus ln x, x squared over 2 plus c. So 1 times x squared is x squared, 2 times 2 is 4. That is your final answer here. Let me show that. Thank you. All right, the next one, number 10, and I'm sorry if it sounds quite different, it's just I put a headset, is the integral of x squared sine 2x. The integral of x squared sine 2x dx. All right, no ln's here, so we can make our nice and onyx x squared f of x equals x squared. So f prime is going to equal 2x. Now, the g prime of x is sine 2x. So we have to do g of x equals, from here, let's remember our rule. If there's a constant in front, we just divide it by the constant. So I'll write it over here, actually. So g of x is going to become, the antiderivative of sine is cosine. So that's cosine. Let me just think. It's negative. Yeah, it's negative cosine. Negative cosine 2x over the constant, which is 2. Okay, so let's start working. F of x is x squared. G of x is negative cosine 2x over 2 minus the integral of 2x. I'm sorry, that's f prime, which is 2x, times the g of x, which is negative cosine 2x over 2. Very conveniently, we could cross out the 2's. We could factor out the negative, or not factor out, we could pull out the negative. So now we have plus the integral of x cosine 2x. All right, we're going to have to do another integration in parts on this one. So f of x is x. So f prime of x is 1. G prime of x is cosine 2x. And then g of x is going to be sine 2x over 2. Positive, because from sine to cosine is positive. So we'll continue. F of x is x. G of x is sine 2x all over 2 minus the integral of now f prime of x, which is 1, and g prime of, f prime of x, and then g of x, which is sine 2x over 2. We can't have the 2 there, so we're going to move that in front. So then we have minus 1 over 2 integral sine 2x dx. Rewrite that. That's going to be 1/2 times, this is going to be this is cosine, so that's negative. The antiderivative of cosine is sine, so cosine 2x over 2. And then that will combine into negative cosine x over 4. All right, so we have this piece, we have this piece, and we have this piece. So we put it all together. So all together, it's going to be negative x2 cosine 2x all over 2 plus x sine x over 2. Geez, that's really smudge. Minus cosine x over 4. Yeah, let's see, am I missing anything? No, it doesn't seem like it, so we're all good. Oh, I am missing something. Plus C. Okay. So we are all good, okay? All right, last and final one, but definitely not the least. X to the cube, EX from 0 to 1 dx. Okay, so you could kind of tell, since it's X to the third, you could grab the hint that we're going to have to do chain rule 3 times. Or I'm sorry, not chain rule, integration by parts 3 times. So let's see how that works out. Equals, so we got, let's just fix this. F is x to the third. F prime equals x through 2x, no, I'm sorry. F prime, and I'll just restart. F equals x to the third. F prime is going to equal 3x squared. G of x is e to the x. What's very convenient, or g prime of x, is the antiderivative of it itself, so e to the x. Okay, so that's your first setup. Okay. Sorry about the sunlight. I can see that's causing the focus to be weird, but all right. So f of x, f of x gx. So that's, I'll start all the way here because I'm going to need a lot of room. X cubed ex minus the integral of 2x to the cubed to the second No, 3x to the third, 3x to the second, ex dx. Okay, I can factor out a 3 here. And then the next one, f of x is a 2x, or x squared. So then f prime of x equals 2x. And then the g's are the same, so I'm not going to bother rewriting that. So this becomes minus 3 f of x, which is x squared, e of x, minus the integral of now f prime of x, which is 2x, e to the x dx. All right, my new f of x, I can move the 2 in front, actually. So my new f of x is x. So then f prime is 1. G of x is exactly the same. So minus 2 times f of x, which is x, g prime of x, which is, g of x, which is ex, minus the integral of 1 times e to the x dx. Okay. Last one, e to the x. The integral of e to the x is thankfully e to the x. So minus e to the x. Okay. All right. So let's just put that all in a line. Okay. X cubed e to the x minus 3x squared e to the x. That's from here. Minus 2x e to the x, which is here, minus e to the x, which is here, plus, oh wait, it's not plus c, because look at this. It's 1 and 0 power. So it's from, so all of this, funny enough, is minus e to the x from 1 and 0. Okay? Now let's do some simplification. Anything to the 1 power is itself. So this is just e, this is just e, this is just e, this is just e. And then these are just all 1s. So let's make it a little easier. Let's do the 1 part first. Okay? So plugging in 1, this will just be e, minus, this is 1, and this is e, so that's 3e, minus, this is 2, this is e. I'm plugging in 1 for everything, so e to the 1 power times 2 times 1, minus e. Okay? Take that and subtract by the 0 power 1. Now anything times 0 disappears. So this will disappear, this will disappear, this will disappear. And then e, so negative e to the 0 power would just become 1. So that's negative 1. So minus negative 1. Since this is all terms of e, I could combine like terms. Negative 3 minus 2 minus 1, that's negative 6, plus 1 is negative 5. So I got negative 5e, and then this double negative is a plus 1. So I end up with negative 5e plus 1. Yeah, so definitely be aware for something like that. Definitely an interesting one, and it doesn't get too complicated simply because we use e to x. So there's no like rigmarole with that, okay? Otherwise, you guys have a wonderful, finish your weekend wonderfully. On the Monday test, as I said, I have to figure out what is the best method for it. Also, I'll put it on the post also. Number 4, do not worry about. That's a different method that we didn't go over. It's my fault we didn't go over it, but so be it. All right, have a wonderful weekend. Stay safe.